Good morning, all. Today we are going to discuss in-text questions. Yesterday we have gone through 4 questions, and I just go with once again from the first question so that it will be helpful for those who were not there yesterday. And before commencing, let me know whether my voice is audible and the screen is visible. All of you can hear me. Okay, fine, Priyanka. We'll start the session. And obviously, when I share the screen, you may have a little bit of problem. Okay, and when I come back, I'll discuss once again if you had a problem. Okay, let me go with the first question. This is carbon dioxide dot structure. How to represent carbon dioxide dot structure? We all know that the atomic number of oxygen is 8 and the carbon is 6. Now how to write that? 2, 6, 2, 4. And 6 is the electrons present in the outermost orbit. And in the carbon, 4 electrons are found in outermost orbit and they are called as valence electrons. Now same thing you can observe here. Around the oxygen, 6 electrons were written. Around the carbon, 4 electrons were written. The dots represent the electrons. Now, oxygen, in order to attain octet structure, one of the oxygen atom shares 2 electrons with the carbon. In the same way, the carbon is not completely filled, so the other oxygen atom shares 2 electrons with the carbon atom. Now, the carbon shares 4 electrons, but each oxygen shares 2 electrons. Now, each carbon shares 2 electrons with oxygen atom, hence the bond formed is double bond. And after writing this, we have to put a circle so that it completes octet structure. Now, oxygen already had 6 electrons in outermost orbit. Now, make a circle along with 2 more electrons of the carbon so that oxygen circle will have 8 electrons. Even right side also, left side also. And in the center, how to put a circle around the carbon? Count 8 electrons either side and put a circle. This is the dot structure. This is very important for your board exam. Okay, anybody had problem when I shared the screen? Whether it was clearly audible? Okay, fine. Okay, fine. Because yesterday we had more problem. So many of you all faced the problem, right? And today I think it's not having any problem and it is very clear. Okay, then we'll move on to the next question. Of S8 compound, S8, the sulfur with 8 atoms, S8. Now even sulfur has 6 valence electron, and you just put 6 dots around the sulfur, and you are supposed to write the sulfur atoms in a wave shape. In the first row you write 5 sulfur atoms in a wave shape, and in the second row you write 3 sulfur atoms in a cone shape. Now look at corner sulfur, left corner and right corner. Both the corner sulfur shares 2 electrons with 2 sulfur atoms. Only the corner sulfur will have 2 bonds. And look at the center one, already one bond is formed. And then you just go with other bond, so that even the center sulfur will also have 2 bonds. Now already one bond is formed and shared 1 electron, and now share the other electron with the other sulfur atom. It continues till the corner sulfur. Now count the number, each electron having 6 electrons. They share 2 electrons with the 2 sulfur atoms, so that it attains octet structure. When you look at all the sulfur atoms will attain octet structure. Okay, clear? Okay, S8 structure. Whether it is cleared or should I repeat? Okay, if it is cleared, then we'll move on to the next question. So, dot structure is very important. Now don't get confused with the dot structure. You already know to put the bonds, right? And the bond is formed between C and H. We already studied this. The bond we used to put between C and C and C and H. Now, we already know each carbon atom forms 4 bonds if it is saturated, right? Then each bond, instead of bond, you put 2 dots. The dot close to the hydrogen one, the dot close to the carbon. It will become 2 dots. And the same way you follow with other 3 sides also. Now, around the carbon will have 4 dots, and very close to the hydrogen 1 dot. Now all the 4 hydrogen will have 4 dots, and the carbon will have 4 dots. Now put a circle around the methane, completely one circle around the methane. Okay, that indicates octet structure. So if you know the structure, definitely it's so easy to write in a dot form. Okay, for each bond, single bond, 2 dots. Okay, my next question is, if there is double bond, how many dots you are supposed to put? Let me know. For single bond, I told 2 dots. For double bond, how many dots you are going to represent? Very good, Priyanka. It is 4 dots. Yeah, Kalpana and Harshita. Good, Manasa. Good, Shubha. Okay. And how many dots you're going to represent if there is 3 bonds? If there is 3 bonds, how many dots should be represented there? Very good, Priyanka. 6 dots. Very good. All of you got the idea, right? If you all know the structure, I already told to practice the structures today. And while practicing, meanwhile, you just practice with the dot structures also. Okay, it will be helpful and easy also. Okay, very immediately, the very next question is, what is the valence electron of hydrogen? Because this is very important. We should have this knowledge while writing the dot structures. What is the valence electron of hydrogen? That means the electrons present in outermost orbit. Valence electrons I already represented with a diagram. Just now, the first question you come to know, sorry, it was carbon dioxide, right? Okay. Valence electrons in the sense the electron found in the outermost orbit. Now, what is the atomic number of hydrogen? It is 1, right? And in the K shell, how many electrons you are going to represent? It is 1. Obviously, if it is not filled, the S1, S2, right? In order to fill the S block, it required 2 electrons, but hydrogen has only one. That will be the valence electron. Okay. Now, the valence electron of the hydrogen is 1. Okay. How many dots you are going to write for hydrogen? Near the hydrogen, you want to write the valence electron. How many dots? How many dots will you put near the hydrogen? No, Kalpana. Just now I told valence electrons represent the dots. Yes, Priyanka answered correctly. It is 1 dot. Because 1 valence electron, 1 dot. Okay? No, Manasa, wrong. I'm asking for hydrogen. Only 1 dot. Near the hydrogen, you will represent 1 dot. Okay, my next question. For the carbon, how many dots you are going to represent around the carbon? Yes, 1 is the right answer, all of you. How many dots around the carbon? Yes, it's 4 because the carbon has 4 valence electron. Try to put around the carbon 4 sides, 4 dots. For the carbon dioxide, it forms the bond with oxygen and it shares 2 electrons. So, in carbon dioxide, 2 dots each side. In carbon dioxide, 2 dots each side. For the methane, it has to share 1 electron with the hydrogen. So, each side 1 dot. All the 4 sides 4 dots. Okay. As per the requirement, you can change the number of dots as per your requirement. Okay. So, while writing the dot structure, valence electrons, knowledge is so essential. Okay. Now, what is the valence electron found in chlorine? Chlorine or halogens? In all the halogens, it is same. Even for the chlorine, it is same. I didn't get any reply. It's so easy. Yes, it is 7 because the atomic number of chlorine is 17, right? How you are going to represent? In the first orbit 2, okay, and in the second orbit 8. So 8 plus 2 10, and in the atomic number the chlorine is 17. 17 minus 10 is 7. 7 is the valence electron of the chlorine. Very good, Priyanka. Aishwarya, wrong. Yeah, correct, Priyanka. 2, 8, 7. This is the way to write the number of electrons as per KLMN shells. Okay, cleared. And the same way for chlorine, bromine, iodine, the valence electrons is 7. Okay. Then we'll move on to the next question. We already know where the compound shows. Write the isomers for pentane. Count long chain pentane. You just imagine from C to C, the line should go from the center. Okay, exactly it looks like plus. Now the first line has 3 carbon and the second carbon undergo branching on either side, and each branch shares methyl group. Remember, CH3 always CH3 represented as methyl group. Okay, now look at the top side, it is CH3. Look at the bottom side, it is CH3. So CH3 represent methyl group. Both the sides it shares methyl group. So just count the number of carbon, it is 5. Either side same functional group is shared. So it is named as neopentane or 2,2-dimethyl propane. Okay, this is how we can represent the pentane as a neopentane. And this is the other form to write the structure. Now 4 carbon atoms are represented in a long chain, and the second carbon shares methyl group, CH3 group. Now count the number of carbon atoms, it is 5. The second carbon shares methyl group. So this is called as isopentane. Why it is called isopentane? Always the second carbon undergo branching. Iso in the sense the second carbon undergo branching. Whenever you can see the branching at the second, it should represent as iso. Okay, even the other name is 2-methyl pentane. Actually the second name is quite wrong. It should be named as 2-methyl butane. 2-methyl butane is the right answer. I think somehow it was typing mistake, I think so. Okay, but you just name it as isopentane. This is isopentane, neopentane, N-pentane. Okay, these are the isomers of pentane. One more hydrogen. For isopentane, yes, it's right. One hydrogen has been left. Okay, I already told, even the name is also wrong, right? And one hydrogen is missing. Yes, definitely. Yes. This is printed material. Sometimes you may have the printing mistake. Even the name is also 2-methyl butane, but they have given us 2-methyl pentane. Okay, you rectify that in your study material. Put one hydrogen bond above the carbon, okay, and rectify the second name as 2-methyl butane. Okay, we'll move on to the next question. If it is cleared, all of you cleared with this? Yeah, Harshita, one is missing. Okay, fine, good identification. Okay, all of you cleared with isomerism, and how to represent in different form, in a branching form, long chain. Okay, if it is cleared, we'll move on to the next question. What are the two properties of valency? The answer is catenation and tetravalency. How to write the dot structure for cycloalkanes? This is how the cycloalkanes are represented. As per the structure, the cyclopentane is written like this. And as per dot structure, each bond has two dots. Now near the H, one dot, near the carbon, one dot. Now count the dots around the carbon, there will be 4. Count the dots around the hydrogen, it is only 1. Now wherever you write the bond, you try to put the dots. Okay, now count the dots around the carbon and hydrogen in total. Then it completes octet structure. 8 completely, it is 8. Around the carbon and hydrogen, you just count, it will be 8. That means it attained the octet structure. Now, finally remove all the bonds, all the dots, all the lines. Now completely you go with the electron dots. Each carbon has 4 dots around the carbon and 1 dot near the hydrogen. and put one circle around the hydrogen and one dot of carbon so that hydrogen attain a complete K-shell filled structure. K-shell has 2 electrons. Now hydrogen reached K-shell maximum number. So it attained a filled structure. Now you look at carbon. By counting the number of hydrogen and the carbon sharing the electron with other carbon, the carbon sharing the electron with the hydrogen, you just completely count and put a circle for 8 electrons. For 8 electrons. If you go on putting like this around the carbon for 8 electrons and for one dot of the carbon and hydrogen, it is 2 electrons for hydrogen. This completes the dot structure of cyclopentane. This you cannot learn directly by the theory. Yesterday I told it. You can learn well by practice. Paper, pencil, practice. Okay? Okay, what about cyclopentane dot structure? That is clear to all of you? All of you cleared with the cyclopentane dot structure? Okay, then we'll move on to the next question. Draw the structures for the following compounds. Ethanoic acid. Ethanoic acid always should have 2 carbon, and along with that carbon it should attach COOH group, and that C is already counted with the 2 carbon. Okay, don't put one extra COOH. COOH should be included in 2 carbons. Bromopentane. Write the pentane, remove 1 hydrogen, join Br. Butanon. Now in the butane you just write the butane and somehow in the center remove 2 hydrogen and give double bond O. That will be butanon. Hexanal. Write hexane. At the last remove the hydrogen, 2 hydrogen, join okay, not 2 hydrogen. You just remove 1 hydrogen and join OH group. Just join OH group, that will become aldehyde. Now look at the structures. ethanoic acid. 2 carbons are there, and among the 2 carbon, 1 carbon will give the functional group as COOH. Now how to write COOH? C double bond O, C double bond OH. Write pentane. Remove 1 hydrogen at the last. You just add Br, bromine group. Butanon. Write butane. In the center, you remove 2 hydrogen for 1 carbon and represent it as double bond O. That is ketone group. Okay, here double bond O, double bond O. Hexanal, you just write hexane, complete hexane. At the last, you remove 1 hydrogen. You have to remove 2 hydrogen. Remove 2 hydrogen and join double bond O. That becomes CHO group. CHO group represents the aldehyde, and that is hexanal. Now how you are going to name these compounds? CH3 CH2Br, that is methyl or ethyl group. If there is only one C, then you can call it as methyl, but it has 2 carbons, so it is called as ethyl group. Always halogen should be named first. Bromoethane. Bromoethane. This is the name given for the first compound. Bromoethane. And here CHO group is given with 1 carbon. 1 carbon means methyl. Okay. Then how to name it as aldehyde? For the aldehyde, Al is the suffix. You should add Al at the last. So how to name this? Methanal. Al. Methanal. Now third one. There are 6 carbon with 3 bonds. So the name is hexyne. YNE. Hexyne. Okay, this question it won't be given for your examination because ethanol and ethanoic acid part has been removed. Okay, but still the question is so simple. Ethanol, just by adding oxygen, it converts into ethanoic acid. So simple to prepare the ethanoic acid by ethanol. How? By oxidation. Oxidation in the sense adding of oxygen or removal of hydrogen. Now ethanol, by the oxidation, it can convert into ethanoic acid, but it won't be there for your exam. This part has been removed. Okay, this is the question, application question. A mixture of oxygen and ethane is burnt for welding. Ethane cannot burn completely to give a clean flame, but at 3000 degrees Celsius, with enough supply of the oxygen, ethane burns completely with a clear flame, and that flame is used for welding. I think it was cleared. Ethane doesn't burn completely with limited oxygen, so that cannot be used for welding. Then how to use for welding? Ethane at 3000 degrees Celsius, it burns completely with enough oxygen to give a clean flame, and that flame is used for welding. Hope the answer is cleared. Okay, what about that? Ethane used for welding process. Is that clear? Should we repeat? Okay, fine. If it is cleared, good. We'll move on to the next question. How would you distinguish experimentally between alcohol and carboxylic acid? This can be easy when we use carbonates and hydrocarbonates. Alcohol doesn't react with carbonates and hydrocarbonates, no reaction with the alcohol. But carboxylic acids react with carbonates and bicarbonates, reacts and they burn and they release carbon dioxide so that the lime water turns milky. When there is carbon dioxide, the lime water turns milky, so that the carboxylic acids turns the lime water milky, whereas alcohol doesn't turn the lime water into milky. So this is how we can distinguish whether the given compound is alcohol or carboxylic acid. Okay. So carboxylic acid and ethanol, the part is removed, so no need to get tensed on this application question. Okay, if by mistake if the question is arised, now we have to think, right? Now how to think? The ethanol doesn't react with carbonates, whereas carboxylic acid reacts with carbonates to release carbon dioxide, which turns lime water into milky. Hope the answer is clear, but no need to get tensed. That part won't be asked for your examination. Okay, we'll move on to the next question. What are oxidizing agents? The substance which gives oxygen or which removes hydrogen are called oxidizing agents. Potassium permanganate is the best example for oxidizing agent. How would you able to check if water is hard by using detergent? No, we cannot identify by the using detergent whether the given water is hard water or not. Why? The detergent gives lather both with the soft water and the hard water. So, we cannot identify the detergent as it gives clear lather, and hence detergents cannot be used to check the hard water. People use variety of methods. Adding the soap, they beat the cloths, they beat with the paddle, they'll scrub, they'll brush and subject it for agitation in the washing machine. Why this type of agitation is necessary? To clean the cloths. We already know that the soap molecule has two ends, hydrophilic end and hydrophobic end. Hydrophilic end is easily soluble in water, whereas hydrophobic end will forms a missile with a dirty present in the clothes. Now all these missiles will form the scum, and that scum will remain as a colloidal particles within the cloth. Now when you beat it, when you brush it, when you scrub it, when you put it in a washing machine, the agitation removes the scum so that further again the soap molecules can form more missiles to make the cloth clean. Okay, Pallavi wants repetition. Okay, which part should be repeat? Which part, Pallavi? Which you need repetition? And all of you cleared with the why the agitation is necessary while cleaning the clothes with the soap or detergents? Okay, if it is clear, no problem. And Pallavi is arising some doubt. She needs repetition. Which part you need repetition, Pallavi? Either cleaning process of the soap or something else? Okay, everybody cleared. But what about Pallavi? She didn't rise, but she needed repetition. Okay, I'll repeat with the soap. Now, soap molecule has two ends, hydrophilic end and hydrophobic end. Hydrophilic end easily get dissolved in water. Hydrophobic end, the hydrocarbon tail, form the missiles with the dirt present in the clothes. When you agitate, that means when you brush it, when you scrub it, okay, that scum will be removed. And when you apply the soap once again, the further dirt form the missiles and the cloth get cleaned. So that is why the agitation is so important to remove the scum or the clumps formed by the soap. Okay, we'll move on to the next question. Okay, alcohol. Okay, Pallavi. But the thing is, that concept won't be asked for exam because ethanol and ethanoic acid has been removed. No need to get tensed. But that is so easy. When you allow the alcohol and carboxylic acid to react with carbonates, alcohol doesn't show any reaction with the carbonates. Whereas carbonic acid reacts with the carbonates and release carbon dioxide along with the salt and water. When it releases carbon dioxide, that carbon dioxide turns the lime water into milky. Now we can identify which is carboxylic acid and which is ethanol. A clear solution represent ethanol because there is no turning of the lime water, whereas carboxylic acid, which turns the clear lime water into milky. So this is how we can identify the ethanol and carboxylic acid by using carbonates and bicarbonates. Okay, if it is clear, shall we move on to the next question? Shall we move on to the next, or you need any repetition here? Okay, fine. We'll move on to the next. Now this requires paper pencil test. So you want to write the structure and then you want to count the bonds. Okay, this is ethane. Now count the bonds. Hydrogen bonds are 6 and C to C is 7. There are 7 covalent bonds. Count the bonds. 1, 2, 3, 4, 5, 6, 7. 7 bonds are there. So 7 covalent bonds. Butanone is 4 carbon compound with the functional group. Which is the functional group found in butanone? ONE1 is the functional suffix that indicates ketone. So butanone is a ketone. While cooking, the bottom of the vessel is getting blackened. Why? So fuel is not burning completely. The unburnt carbon particles deposit it on the bottom of the vessel and makes it black. This is because incomplete burning of the fuel. When the vessels get blackened, only by the incomplete burning of the fuel is the right answer. Now explain the nature of covalent bond using the bond formation in CH3Cl, that is chloromethane. This is the structural formula for chloromethane. Chlorine has 4 valence electrons in the outermost orbit, and each hydrogen has 1 valence electron, so that hydrogen share 1 carbon electron. In the same way, the chlorine has 7 valence electron, even it shares 1 electron with the carbon. So this is how the dot structure explains how the valence electrons helps in the formation of covalent bonds in chloromethane. It is completely based on valence electrons. Now you want to draw the electron dot structure for ethanoic acid, hydrogen sulfide, propanol and fluorine. Ethanoic acid, you know how to write the structure of ethanoic acid. CCOOH and COOH, one single bond with OH, double bond with O. Okay. Now, wherever you write the hydrogen, put 1 dot, around the carbon 4 dots. But in the center, when it attaches to the oxygen, remove the other hydrogen, 1 hydrogen, so that it forms double bond with the oxygen. Okay, oxygen will have 6 dots. It shares 2 dots of the carbon. Remember, it should share 2 dots of the carbon as it forms double bond. And then oxygen. Oxygen, instead of here oxygen, we already know that the bond is OH bond. OH in the sense single bond. Oxygen require 2 electrons. Oxygen shares 1 electron with hydrogen, 1 electron with the carbon, so that oxygen attains octet structure easily, and this OH shares 1 electron with the carbon. Okay, this is quite confusing. You just practice more times. This is how, in a simple way, we can write the structure of ethanoic acid. And this is the dot structure of ethanoic acid. Now hydrogen sulfide, even sulfur will has 6 electrons in the outermost orbit, and it requires 2 electrons, so it shares each electron with the hydrogen, so that it shares 2 electrons with 2 hydrogen atom. Next, propanol. Propanol means ketone group, CH3COCH3. CH3, it is so easy. Each carbon shares 1 electron with the hydrogen, both the sides methyl group. In the center, remove 2 hydrogen and make 2 electrons sharing with the oxygen so that it forms double bond. Look at the structure. C double bond O, and look at the dot structure. C 2 dots and oxygen 2 dots, that is 4 dots. That is double bond. Now look at the fluorine. Each fluorine has 7 dots and each fluorine shares a single electron with the other one so that it forms fluorine single bond. Okay, I'll just back within 5 minutes. Just hold on. Okay, now what is the functional group for alcohol? What is the functional group for alcohol? Manasa N should be capital. Okay. Shubha, you left oic acid. You want to complete it. Oic acid. Yeah, OH is the functional group of alcohol. Good, Kirti and Kalpana. Okay, we'll move on to the next concept, next question. What is an homologous series? The organic compounds having same functional group, same general formula, and same chemical properties, and the alternate compound differ by are called homologous series. A series of organic compounds and each alternate compound differs by CH2. Example: alkanes with single bond, alkenes with double bond, alkynes with triple bond, cycloalkanes with the closed ring structures. All these shows homologous